Hey guys, welcome back. This is the 100th episode special on Physics Help Today. We'll be going over momentum today, so let's get right to it. This is bad. Shoot!
Hi guys, welcome to the wonderful world of momentum. Momentum is defined as mass times velocity. The SI unit of momentum is kilogram meters per second. Almost everything in our observable universe has mass. If an object is moving, then it has momentum. The amount of momentum an object has depends on two different variables: how much mass is in the object and how fast the object is moving. Momentum is a vector quantity. A vector quantity is a quantity that has magnitude and direction.
Practice problem!
Figure out the momentum of a 1,000 kilogram car moving north at 20 meters per second. The answer is 20,000 kilogram meters per second north. An object with a change in velocity, acceleration, a net force must be acting on it. Since momentum is directly related to velocity, a change in momentum requires a net force.
Alright, y'all got that?
Wasn't that just magical? All that work to find out force equals momentum over time. Don't you just love physics? Oh my god, don't you just love Newton's second law? It states the next external force acting on an object is equal to the time ratio or rate, whatever, of a change of the object's momentum. Momentum.
Conservation.
For
A.
Collision
Occurring.
between
Object.
land. Whoops.
Whoa.
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 Oh my god.
Did
You
just
say
land? Let's
redo
that
conversation.
back
Two,
objects
one,
and
two,
in
and isolated
system
the
total
momentum
of
the
two
objects
before
the
collision
is
equal
to
the
total
momentum
of
the
two
objects
after
the
collision.
any
Momentum
was
by
the
first
object gained
by
the other.
So, as you can see here, these are two truly inelastic and elastic, what do you call those things?
Collisions.
Collisions that are just amazing because physics is just awesome. You can... Alright, I'm done.
Welcome to Doodles with Jesse. Okay, we're back. This time we're doing impulse, which is the change in momentum. So, yeah. You want me to draw boxes or more elaborate things?
You can do whatever you want.
Go to town. Nice.
Literally
We go,
anything
we go.
you want. Because
We go.
Bo won't care. Because he actually likes you.
Oh, there it is. There it is. There it is.
That sucks.
Greatest part of the video.
You need to include her in that.
Oh, definitely. Yeah, I'm just gonna let him run, Jesse. So
Yeah.
doing all this.
Okay.
Oh! You did break it, you bastard!
Talk.
What?
Talk.
Oh, well, as you can see here, momentum had taken place, but when it hit the ground, it was a change of momentum. And this is called impulse. Now, impulse is the force times the time of an object. And since the asphalt was not very pillowy or anything, the time was there was not much time for the egg to change momentum. So the force was so great in the egg that it caused it to break, and that is why we do not have an Easter egg anymore. Thank you.
Yeah.
Time to throw it up. As you can see here, the egg is not broken. This is because of the gracious pillow on the street. So, because the pillow is so fluffy and elegant, it gave the egg more time to change momentum, therefore decreasing the force on the egg as it hits the street, causing the egg not to break. Thank you.
Fluffy elephant?
I said fluffy and elegant.
I know, but what?
Hello class, today we're going to be learning about the Newton's laws. There's 3 of them. They're pretty big, they're pretty important in fundamental physics, what we're going to be going over today. So hopefully you'll be able to understand them, or if you don't, I'll hopefully clarify it so you can understand them. So we're going to get right into it, guys. The first law is Newton's first law, and it's covers static equilibrium.
So yes, as Lucas said, Newton's first law is static equilibrium. Basically what this states is every body continues in its state of rest or of uniform speed in a straight line unless acted on by a non-zero net force. And let me dumb that down a little bit. Basically, it's saying that an object in motion will stay in motion, and an object at rest will stay at rest unless acted upon by an outside force. And you know what? That's a pretty basic one. It's pretty basic. It's easy to understand. So on to Newton's second law, dynamics of a single particle. And I think everyone's a little familiar with this one. F equals ma.
Like, that's pretty big. Like, we can calculate most things in this world just from this simple formula. Like, if you want to calculate the force of you hitting the wall, just know how fast your hand's going, know the mass of the wall, match your hand, and you're good. You can calculate anything you really want.
That's basically what it is. This whole law, F equals ma. And this is for force equals mass times acceleration. The unit of force is the Newton, abbreviated with a capital N. A Newton is defined as a kilogram times meter per second squared, which is basically the mass, kilograms, times acceleration, meters per second squared, that's equal to a Newton. I mean, it's pretty basic, it's very easy to understand. And Lucas, why don't you take it away for Newton's third law?
So we're gonna go into Newton's third law. So pretty much, this is pretty simple, pretty common sense. If you don't understand this, then well, we're gonna go over for you guys. Newton's third law states for every action there's an equal and opposite reaction. So like, say I go up to my pal over here, Evan, and fist bump him. We're both gonna feel the fist bump, because if one person doesn't feel it, then it doesn't make sense. Like, if you fist bump something, you're both gonna feel the force acting on it. So that means equal and opposite. Not one of you's not gonna feel one stronger than the other, because you both are gonna be like, solid fist bump. You're gonna be like, ow, my hand hurts. You know what I'm saying? All right. So that's pretty much the Newton's laws. I mean, we can go into a little free fall if we want to. I mean, unless is this in the lessons plan, Congress? And we go into free fall? No. Just Newton's laws. So I think we covered it. I mean, I think we're gonna send it over to Connor and do a little bit of practice problems.
Tiptoe through the window, by the window, that is where all becomes.
This is Florida.
With me.
Pull it out. Let's see what happened. What happened, Patrick?
I don't know. I was sitting in my chair and I heard a crack, and then down I went. Oh my god! It literally broke.
We'll keep the showers away, and if I kiss you in the garden, in the moonlight, will you pardon me and tiptoe through the tulips with me? Will you pardon me and tiptoe through the tulips?